We have a regular polygon with 42 sides and a regular heptagon with 7 sides next to each other. And we're trying to show that BCD is equilateral. BCD, this triangle here. Now, the first key thing to note is that AB is shared by both sides, and so they have the same length sides because they're both regular polygons. And that means BC is equal to BD. So we've already got an isosceles triangle. Same length sides. So if we can work out this angle here, we're sorted actually. And I'm going to show you two ways to do this. I actually did it a slightly longer way, and that is to look at interior angles, but it's not too bad. So let's have a go. We've got a heptagon here, so we can take the number of sides minus 2 times by 180 and divide by 7. That'll be this angle here. I'm actually not going to work out what that is. It's going to be a mixed number. Just going to leave it like that for the time being, because I can do exactly the same for this one over here, which is going to be 40 times 180 over 42. Now note, I can divide through top and bottom by 6 to give 40 times 30 over 7. So I can put them over a common denominator. And then I'm going to, should I add them together? Yeah, let's add them together because then we know in total this is going to be 360. So 5 times 180 over 7 plus 40 times 30 over 7. Well, we've got 900 here because it's just 10 times 180 divided by 2. That's 900. And then over here, 1,200. These are both still mixed numbers, but when we add them, we get 2,100 over 7, which is 300. Brilliant. So that means, therefore, angle CBD is equal to 360 minus 300, which is 60 degrees. Hence, angle BDC and angle BCD are both 60 degrees too, since triangle BCD is isosceles. And that's the result. Result proven. Triangle BCD is in fact equilateral. Nice. Just going to show you an alternative way of doing this problem, and that is to instead look at the exterior angles. Because for this, if we draw this line that kind of just extend AB basically, there we go, then actually this angle here is the exterior angle of the heptagon. So it's going to be 360 over 7. Whilst this one here is the exterior angle of the 42-agon. So it's going to be 360 over 42. Remember, we've got our overriding isosceles triangle as well. And we're going to use the same kind of argument after we get this angle. We're going to show this one's 60 degrees. So we can factorize out the 360. Well, actually, let me just write down 360 over 7 plus 360 over 42 is going to be 360, 1 over 7 plus 1 over 42. Put it over a common denominator, so 42. So it's going to be 6 over 42, because I've times top and bottom by 6, plus 1 over 42. Seven over 42, which simplifies to 360 times 1 over 6, or 60. Okay, and then we make the same argument as before once we've got that 60 degrees, like I'm basically at this point here. So two different methods, both show that BCD is equilateral. Nice.